Hi guys. So this is just a recap on the pulse charging circuit that limited list potential posted. He might have some different parameters and stuff that are making his work, but I haven't been able to replicate it. I was able to do it when I was doing it manually, but I think it was just because the batteries had been sitting for like 3 months and they were just coming back to life. And nothing was consistent on those tests either. This is down to the second here. Everything's been switched, and the pulsing circuit is unaffected by any of the switching. The the power supply is what gets turned on and off. The pulsing circuit is not affected at all. There's no extra circuitry on the pulsing circuit. It goes the only switching on the pulsing circuit that is different is there's a switch on the power supply that powers the circuit. It's just an on and off switch, so that's all that changed there. It's no different for me unhooking the leads with my hand, but now it just has a switch. It's identical. It's the same exactly. It's 169 hertz, pulsing the microwave oven transformer coils, and the flyback is what's charging the battery. It's in a charging state here right now. It's on still, and this is being monitored right now. And there, it just turned off. Because now you see it coming back down. The original resting voltage of this battery that had been resting for over a week was 26.32, which is right here. You can see this is the latest chart here I have, but I've just taken some screenshots of this, or saved pictures, you could call it, not screenshots. So I'll bring those up so I can do some lines on it. So this is the most recent one here. I just finished taking this screenshot. What was it 12 hours 37 minutes? Now we're at 13:06. So let me draw some lines here on this and you'll be able to see. So now the circuit just turned on. You can see it's doing a discharge here now. So you're going to see it come down like on this down here. It's actively doing that or as we speak here, or as I speak. But I'll draw a line here on here just to make it visible so you could see. So start at the bottom. So you can see it's dropping. This was the resting voltage up here. This is 26.32, and now it's not even hitting that voltage anymore. It's coming down here to, I think that's 26.29 volts. Well, you can see where last time it was at, the resting voltage was here about, what, 7 hours ago. And you see how much that has dropped. And then this is the top charging voltage. And you see how that's dropping. I used to hit 26.48, 481 or something with it was when I first started this. So that's that one there anyway. You can see how much it's falling in these hours. So let's just go to the next one. I have another one saved here. It's 22 hours, 22 and a half hours long. So there's a couple here that are different. This one I pulled an extra minute. Or no, it was 30 seconds. I pulled out extra on the discharge. That's why this one's a little bit longer. But it still was able to recover a little bit. It was still It was coming up and now it's starting to go back down. And I did the same here in this one. This one I think was an extra minute. That's why these ones are different. But according to limitless potential, you should be able to pull extra. Like when he did his demo, he was just doing stuff manually and nothing was consistent at all. And he claimed the voltage was rising. He even claims right now that he's got two batteries being swapped back and forth, running LEDs. But I don't know. I'd like to be able to see that. I'm not saying it's not working for him. Like it might be. I just his parameters are different. I guess. Oops. It's not working for me with it the way I'm doing it. And I go by real data that runs for a really long time here. So that's a little bit higher than what I'm. I see is falling, but I'm a little bit high on this end over here. And just redo that. Now you can see, oops, overall it's falling. It's interesting though, it just shows how the batteries react. The resistance inside the batteries change. Try this here. Here, this is a little bit high, but you can still see is a pretty big voltage drop here. And this is where the resting voltage was. It had been there for a really long time. The only thing that was changing is the length of time before it recovers. You can see it gets longer and longer. That's the time right here, right? And this is where it starts to charge. Even the charging characteristics change. So there, it just turned off. Now it's about to rest again. So it charges for 10 and discharges for 5. And there's 1.77 watt hours going in, and there's 1.83 watt hours coming out. So it's really close to 1 to 1. There's just a little bit more on the output. And you can kind of see it in the graph, the way the battery's reacting. It's acting as if you're pulling power out of it, like with a really low load on it. So that's the data I have for that. I also did a conventionally charged, and I have data for that too. And I did that one with a low voltage on the other battery. I discharged 10 amp hours out of it. So let me pull up that one. This is the curve I did. It was just the other battery. It was resting at 26.29. This one was resting at 26.32 when I grabbed it. So you could see I pulled 10 amp hours out of it in 5 hours. So I pulled a 2 amp draw on it for 5 hours. And I was testing it in this area here somewhere, I think. So this is one of the first ones. And this one I was pulling a little more out of it. I was putting the same watt hours in, and I was pulling a little bit longer. I was pulling for 7 minutes instead of 5. And it was almost 2 watt hours coming out and 1.77 going in, conventionally charged. So that's the first part. It was resting here. That's the resting voltage, and then this is the charge, discharge. Then I think I have more graphs. This is the next set. This is more 11 hours of it. You can see how much is dropping. And then here's a little bit more. Another 11 hours. So that's conventionally charged. That's what it did. It's definitely dropping faster though, but I was also pulling more out. 2 extra minutes on the discharge. But that's about it for this video, guys. Just wanted to share that information anyway. There's, like I said, the circuits, the switching circuit has its own power source. There's nothing being affected by it at all. Like the battery has no extra draw on it because of the switching circuit. How the switching circuit is doing is turning on the load and turning it off and turning on the power supply and turning the switch off from the power supply. That's it. So that's all there is for this one. I'm not going to waste any more time on this right now. I don't have enough time. My days off to do this, so I'll be working on some other stuff. But appreciate watching, guys. If you're going to do this circuit, I'd recommend doing it like a long-term test. Don't do like I did before with just 4 or 5 pulses and call it good. Because lithium iron phosphate takes a long time before they come out of their flat line. Like you can see right here, this line right here, this battery was at 40% because it's a 25 amp hour battery, and look how long it flatlined here. It even went up right here. See, when you first start discharging it, that's what happens with batteries. Put a load on them, they recover. It looks like there's power going in, and then they start to drop like normal. Every battery does that. Always. I've never seen a battery not do that before. There's always a little bit of a recovery as the chemistry wakes up in the battery. It comes up and then it starts to go back down. And lithium iron phosphate could take a long time to do that, depending on the size of your battery and your. This could be many hours, and it might even keep going up for many hours before it starts to come back down again. Long term, I don't think it's gonna keep going out. The only way I've been able to get it to self-sustain is with a pulse motor with north-south on the magnets, and when you're charging 1 to 1, that's like just enough to sustain itself. It hardly has any extra energy at all, unless you're charging at a higher voltage, like 2 or 3 times the voltage that's going in. You're not going to get much extra, in my experience anyway. Other people might have found different ways to do it, but I've not been able to do that. Anyway, thanks for watching, guys. Appreciate it.